Hey, John here. So what happens when you decide you want to make some changes to a design and then propagate them into your PC board and just, redo stuff? How does all that work? Well, let's focus first on this one connector over here. Let's say you don't want to use a barrel connector anymore and you want to make a USB powered board. I mean, I got a lot of USB power supplies around the house. That sounds like a reasonable thing to do. So maybe you're going to come over here and you're going to delete this part. You're going to delete the whole symbol and its footprint because they're going to replace it with a USB jack or something. Now remember, this is J2, okay? And also this is going to come into play. So let's remember this is, this is an old, it's symbol ID. Every time you create a new symbol, KiCad's going to put a different value in here. So you don't really need to remember this one. You're going to know if I delete it and put a new one in there, this value will change. The reference J2 I'm going to set to the same value as this because I just want to replace that with a different part. So now that we've loaded up the DigiKey libraries, we can get some nifty USB connectors. You can get some out of here too. I did a version of this where I used some of those and it was fine, but I prefer the symbols that you can get from the DigiKey library instead. And there's a bunch of USB junk. Here we go. I actually got a bunch of these lying around the house right here. Okay, this guy right here, let's use that one. What do we got? What do we know about this? So it's not annotated yet. This thing, as you recall, ended in a B4. Now it ends in a DD, so clearly that's different. The other part was called J2. I want to make this J2 as well. We can hit OK. Now I happen to know that when you're dealing with a USB connector, this here is your 5 volts. Pin 5 is ground. And you're going to want to, connect that to here. All right, save. Now I've just replaced this thing. Now technically the schematic's wrong. I'm going to need to delete this stuff and clean that up too. But let's look at just making this one change. Play around a little bit with the PC board editor now that we've done this. So I'm going to create a generate a netlist, save it. Let's go over here and open up the PC board. All right, so what are we doing? We want to replace this part here, right? Well, what really happens when you click Netlist? Now let's look at these buttons up here. Do I want to use the reference or the timestamp? The timestamp is this ID that we were just looking at in the schema thing right here, okay? This guy down here, symbol ID. So the other one was something rather that ended in a B4. This one's a DD. So what it really is giving me the option is that, look, when I merge the old netlist in with the new one, do you want me to consider all the parts whose reference numbers are the same as the parts that they are to replace in the PC board? Or do you want me to say if the symbol IDs match, I'm going to replace those in the PC board editor? Okay? This is very handy because quite often you do need to re-annotate your project. Maybe you don't want to use single-digit part references. Maybe this thing grows and you want to start them all with J10 or J101 or something like that. How do you do that and without confusing everything? Well, if all you do is re-annotate your board and do nothing else whatsoever, you would know that all the symbol IDs have stayed the same while the reference numbers have changed. And if that was the case, then and only then, you'd know that inside here, you really want to hit timestamp when you merge those old changes in with the new so that all the parts stay the same and the reference numbers change. If you chose reference in that scenario, what would happen is then you'd have to decide on what to do because it would want to delete the old footprint and put a new one in. So do you want to keep the old ones and add the new ones, which would double all the parts in the PC board? Or do you want to simply change the old ones to the new ones? All right. I would not mess around with any of that, and I would use the timestamp in that specific scenario. And then what would happen is the PC board editor, when you're done with that, import would simply change all the silkscreen values and you'd be done, and which is exactly what you would want in that case. In this case, what I've done, I've changed the symbol of J2. I've kept the reference the same, and I know that the reference ID has changed, and what do they call that darn thing? geez, it's so nice. They call the timestamp here and the symbol ID in the other one. Now, hopefully they'll clean all this up in version 6. But the part reference is the thing I kept the same. The timestamps were different. And what do I do in this particular case? Well, I want to replace it in this case based on the part reference. If I keep the old footprint, what it'll do is it'll add a new footprint and I'll have two J2s in this design. What I really want to do is change the footprint when the references are the same. And there won't be any extra ones if I do that. If I say keep, I'm going to end up with 2 of them. So in this particular case, I want to say J2 is J2 and change the footprint. So I'm going to go like this and watch what happens. Bing, that thing changes. I'm all green down here because it's okay with that. And it's going to put this thing where the other one was. Now, of course, this is useless because it's not wired electrically the same way. And I'd have to, move it around. It's tiny, so I might have to move it to the edge of the board, reroute my board and all that. But this is what you need to do if you want to change that barrel connector to a USB connector and have the same part reference. So I'm going to hit Control S to save this, go back to here. Well, what else do we want to do? We want to, well, we don't need the 5-volt regulator anymore, so let's go in here and just delete all that. I'm going to put the LED over here. I'll show you something else in a minute. What else am I going to do? I'm going to change this. All right. I'm not going to call this just power flag anymore. An unknown value of a power supply, right? If I hit Control E on this part, it opens up this part editor. And we talked about this before. All these pins are marked passive right now. So this doesn't say, hey, I'm supplying any power. All right. So the board doesn't know that this is 5 volts and that that's ground, because the way this was defined. So that was why we had to put the power flag in there before. So I'm going to, instead of putting just say power is on here, I'm going to say that 5 volts is on here. I'm going to call this thing, where the heck is it? Plus 5 volts. Right there. All right, so now I can, this track, this net in this design is known by that name. So what I'm going to do now is I'm going to grab this and hit delete. And I'm going to name the net over here as well. I'm going to call that one plus 3.3 volts. Okay. And, you can either call this 3V3 or 3.3V, whatever notation you want to use. All right, so now this one is known as 3.3 volts. Now, the reason I want to do this is just like the ground. I mark this as ground and that as ground. The schematic editor knows these are the same signal, even though there's not a wire drawn between the two, okay? I can now go over here and hit C to copy this, and I can put the 3V3 down there. And I can just hook up this LED, leave it the, zoom in a little bit here. What do I say? G to grab the end of that thing. Oh, come on. Wow. Oh, for crying out loud. It's M and move it to the end, okay. This thing, the junction, I can hit delete now. Come on, junction, okay, there we go. Save, okay. Clean that up a little bit. Now this is going to be powered off of 3.3 volts. It's no longer going to be a 1K. I'm going to put a 330 on there, the lower voltage. Like so. All right, so now he's 3 volt powered, and that's my indicator that the power's on. 3 volts, 3.3, and it could flow through. I could do this, but what I also want to do is put some jumpers on here so that I can make this jack be either 3.3 volts or 5 volts, depending on where the jumper is. So make this a little bit more flexible. So I'm going to remove those markings because they're no longer going to be fixed. No longer be a fixed voltage. All right, I'm going to move this capacitor in a little bit closer. Okay. Now what I'm going to do is I'm going to remove these traces. Delete. I'm going to hover over the end of this and hit delete. Hover over the end of that and hit delete, which probably would have been a cleaner way to deal with this mess I had a second ago down there. All right, so this regulator is going to sit on its own like this. All right. Now, I'm going to copy this guy down here and put an extra capacitor up here just to add some more filtering. Move him a little bit out of the way. Oh, let's get this out of the way. Move him over here. Okay. I'm going to go over here. I'm going to click the end of that and hit G, and I'm going to slide it in like this. And I'm going to, what am I going to do? I'm going to move this up like, I'll just get it out of the way. Okay, there we go. Grab a trace. I'm going to hook it up across like so. Hook it up like so. Then I'm going to make this other one look basically the same way. I'll make them look nice and the same. Hit G and move that one in like the other guy. There we go. Save. All right. Now J1 and 3 are just unlabeled outputs, and they're going to sit here like this. Now what I'm going to do is I'm going to put a net name on here and there. What's a net name? Well, just like when I put a 3.3 volt here and a 3.3 volt there and a ground here and a ground, that named and made these nets meaningful to the to KiCad. Now I'm going to go ahead and name it. See this guy here with the A over the wire? It says place net label. I'm going to put a label on here, and I'm going to call this one VOUT1. So this is the output voltage number 1. Then I'm going to put another net name down here and call this one VOUT2. So this is just the same kind of thing as just putting those voltage power flags on there with a voltage on there, but I can just name it whatever I want. That's what these things are for. And by the way, how they're bound, if I type move and I move this around, you see this dot, the bubble here, that little terminal down there? Whatever that terminal touches becomes Vout2. So for example, if I rotated it like this, that's still on that wire because that's where this box is, right? If I move this down here, it's touching, that labels it. And of course, no one does this. That's foolishness. That's not how anyone does it. You want to do it like this so people understand your notation. So I made a copy of C4, and in doing so, what it did is it copied the footprint, but you'll notice the symbol ID that ends in 213 here. If I edit this one, it gave it a new one. Now I'm 545 because it's a different symbol. So what do I got? C4 and C1. Now C2, C1 and 2, and then 3 and 4. C3 used to be hooked up to the other regulator. Now if I make this C3 here, now I have to deal with, when I merge this, the fact that C3 changed its value from the perspective of the PC board editor. That's actually okay. It turns out the footprint doesn't change by coincidence because all these were 1206s, or I don't even know what they were. These are all 0805s, yeah. All the capacitors are the same. So the footprint won't change, but its value will. No big deal. And also it'll be connected differently in the schematic, of course, because I repurposed it. All right, so what do we got now? We got Vout1, Vout2, you got your 3.3 volts, and this guy's hooked up. You got a nice fancy connector over here. Let's put some headers on here so we can jumper select the voltages using a whatever. I'm going to use a 01 by 03, a generic one like that, okay? Let's rotate it around. What do we really want to do? I could put these anywhere I want, and I can make use of those net names now. Let's say C to copy that, put it down here. These are not yet annotated. Let's make this one J4, just for fun. And this one can be J5. And again, they're going to all have new symbol IDs because every time you create one, KiCad automatically generates a new symbol ID. Now, how do these things work? Well, I'm going to take a wire out of here, and I'm going to hit K to end it right there. Wire come out of here and hit K to end it there. Now, I can either grab another net name and type it in again, or I can go to Vout1 and I can hit C and just copy this and put that there. Hit C over this guy and put that guy down there. And now KiCad knows that this wire here is the same thing as if I drew it up to there. And this wire here is the same as if I drew it over to there. But it keeps your schematic a little bit neater and when things get busy. This is a small and trivial example for illustrative purposes, normally I would put the connector over here by the headers and make it a little more obvious. But this is just, for educational purposes. So on here now, I can come over here like this, and I can hit K, and I can run another wire over here and hit K on that one. And I can say copy this and hook 3.3 volts up to there, and I can copy this, or I can go place another symbol and place 5 volts down there. And I'll do the same thing to the bottom one. I can even copy a wire if I want to, if I can select it, see, and then place it. Oopsie. Grab it. Oh, well, it might be easier to draw it because it's too busy over there. I can hit W, bring this over to here, hit K, hit draw this one over to the same place. I want it to look the same. Hit K, and I forgot to close this, so I can hit G and drag the end of it over there. Hit C to copy this and put it down there. Hit C to copy that and put that down here. Save. Now what I got is a 5-volt regulated source driving a selectable jumper headers that allow me to put the 5 and 3 on either one of these two, and it also runs through the regulator. I think we're good. We can save all this fun stuff. We should go ahead and design rule check because we just hacked this thing to death. And we got no pin to drive. Oh, look at this. And so on. No connect symbol and so on. So what do we got? Close. No one's driving +5. Okay. Oops. You do need to keep a power flag on there. Copy. Because +5 alone, I thought it indicated that that was a power flag, but that's okay. So we all learned something. And then, of course, these aren't doing anything. So what do you do with spare pins? You go over here and say, I don't want to connect that. I don't mean to. Put X's on there to shut up the DRC. Save it. Run the DRC again. Delete them. Run. Now we're good. Okay. Close. So this, according to the DRC system anyway, is okay. I'm pretty sure I connected everything. It's hard to do this while talking because you never really know what you forgot to do. Let's go ahead and create a netlist. Save it. Let's also go over here. Where is the assign PCB footprints to make sure that I didn't forget a footprint on a capacitor or something like that. So remember how this, what's going on here? JB KiCad font. Well, that's because another video I was making some libraries and I deleted them all while we come back to do this episode. So these connectors, good thing I did this, don't have footprints. So I want to edit this, create footprints for them. All right. So that's a preview of a future episode when we're going to talk about making symbols and libraries. What am I looking for? Connector. Remember this game. Make sure you got the right spacing. 254 is your standard 1/10 of an inch style. You want a 1x3 vertical. That's the one I want. Same with this guy. He's already selected from the last time. Now we're in there. Save. And make a new netlist. Now at least all of them have footprints. So what are we thinking about here? What do you think we're going to do when we go to import this netlist, right? Well, I didn't reuse, I did reuse C3 in a different purpose, but C4 is new, J4 and J5 are new, and we already did the update on this. So I think we're pretty good by just using pretty much the defaults. When we're in here, let's think about that again. So the reference should work fine because we didn't really change an annotation in any weird way. If we did we change any footprints this time? No, it wouldn't matter what we did here. And we're not, well, actually we are deleting some parts, right? If I leave this on keep, what'll happen is all the old regulator and stuff will be in there. And I can show you what happens. We can go ahead and do that. What happens is you can actually import the same netlist more than once. So we can see in here we're all green. And some of these info might say something like, oh, by the way, I saved some stuff that's gone now, but I've added all these new ones. Okay, so let's go ahead and close this down. What did we really add? We added these two headers, really. That's all we did. But we also deleted one of these regulators, and I think either repurposed or renamed one of the capacitors, right? And so that's all kind of munged up. You can actually read the same netlist in again. It will do nothing if you use the same options, okay? And that's all the info right there, okay? Let's do it one more time. And this time, let's delete the extra footprints, okay? So if we did delete extra footprints the last time, it would have added this guy and it would have removed a bunch of parts. Let's move this over here so we can watch them go away. If I say read it in, you just saw a bunch of stuff go away. God darn it. Some of the footprints it removed were by the way, those open source hardware logos. Because remember, we added footprints while editing this. Those are not in the netlist because those didn't come from the schematic. It turns out there's actually ways to put them in the schematic so that they stay here, but that's not what we did the first time. So anyway, it removed the two. These are the two OSHW logos, and here's U2, which is that other regulator. Okay, close. So now we're in sync with the schematic as far as all the parts go. These traces are all foolish, and they're probably hooking things that are not supposed to be hooked up anymore because we repurposed C4 and so on. So let's go around here and just delete a bunch of traces. Basically delete all of them. Just move these parts out of the way. You can grab a couple of more than one thing at a time, like sort of like I tried to do there but failed. Let's just move it over here out of the way. Let's just go ahead and draw a rectangle around all this stuff. Delete. You just delete all this stuff. We're gonna redo. Certainly, it's not gonna say 5 volts there anymore because the headers are gonna be selectable, right? And we gotta select which track to delete, and delete. We can save some of the vias. Let's go ahead and delete the track, delete the track, delete tracks, delete that track, delete this track, and move this part. Come on. Get that out of the way. Let's delete these guys. Now this is a pretty hefty change, so we're going to basically unroute the board and reroute it. Some of the other PC board design tools like Altium have a button you can press that just says unroute everything. Just delete all the tracks. Maybe this has one too. If you know where it is, let me know, because I do this from time to time. And this is a pretty simple board. I'll just reroute it. Sometimes you may only want to reroute parts of it, and you wouldn't necessarily want to unroute the entire board, but in this case I would. And it would be nice if there was a simple button to do that. So what are we going to do? We're going to jockey things around a little bit and make this finish off our new design idea. Let's rotate this around. This time I'm going to try and shrink the board down to save a few pennies. They don't cost that much anyway, but let's see what we can do here. So this connector is actually on the other side of the board. So I can actually move this up and overlap these courtyards. Now, if you're going to use this connector, what you need to do is look at the drawing. I don't understand why they didn't put a reference line in the footprint. This is a DigiKey footprint library. It turns out that if you use this, the part that I chose is a flange on the end of it, and it has to hang over the PC board or it won't fit, because the flange has to stick out down through underneath the board. These have holes in here, but the pins that go in these holes are only for registration. They don't actually go all the way through the board, so they're not going to hit anything underneath. If the plastic housing of this reaches down underneath here, you're okay. At the moment, I'm not even overlapping the courtyard lines, these white lines. Let's go ahead and do that to minimize the size of this as much as possible. Now, if you open up the data sheet for this part, which we can do, let's go ahead and open it up, right? It's a DigiKey part, so they have the DigiKey links and stuff in here, right? There's the data sheet. Oops, come on. Oink. Copy. Let's open up a web browser. Oh, there you go. Oh, look at that. I must have killed the web browser earlier. This is the part right here. Here's the DigiKey photograph of it. You see these little 4 pokers? They're going to just set in those holes, and these are only going to stick out. This is a pretty tiny part. It's only going to go halfway through your PC board. So here's the drawing. You can see the flange here. It says 2.15 maximum, and it says when you make your footprint, there should be a PC board end. They should have drawn this reference line into darn footprint. And that they recommend at 1.45 millimeters. So if we go back to the PC board and we look at this, if I hover over the middle of this connector, see these dots? This is your grid reference points. So this dot here, if I put my mouse on here and I look down, this X value down here is what I'm looking at. That's going to say, what am I at? 116.95 or 117.0. I got a pretty fine grid. What is the grid set to on this thing? Wow, that's pretty tight. Let's set it to 1/10 of a millimeter. So this guy right here is at 117.0. All right. So if I move in tenths over to the left, I'm at 987654321 0. So right. So we're at 117.0. I'm at 17. Where am I now? 115 and a half. So that's 1.5 millimeters away. The recommendation was 1.45. So this is in a good position. And it would have been nice if they put on the fab layer, which is this gray line here. If you click on fab, this just comes to the front. It would be nice on the fab layer if they put a line in their part. I could add it if I felt like it, but if I did that, I'd be modifying the DigiKey library, my copy of it anyway, and that's fine. And I can go ahead and use it, or I can make a copy of this, put it in my library, whatever I wanted to do. If I use these a lot, I would do that, and I probably will when I get to the episode on how to make and edit your own part libraries. So let's go ahead and just put this board together. I've already done this. We've done this once before. Let's just clean all this stuff out of the way, and I'll fast forward through all this, and we can just route this board and send it out for production. What am I going to do here? Okay, so that looks like we got all the parts we want. You'll notice I put these capacitors right in the middle of these headers here, and this big mess of yellow is because I forgot to redo the polygon pores. Okay, save, Alt 3, there we go. That's looking a little bit better. Of course, I squished the board down so we can bring this edge way up here, and we could probably save $1 or $2 on the PC board order. Now, it's actually perfectly okay to put the capacitors like this because, you know, they won't interfere with the housings or anything on these headers, because they're on the other side of the board. This, it's kind of sloppy or weird looking. There's certainly, over here, there's certainly space to put it, but I like the symmetry, and I like to be able to smash this up as close as I can. And I might not even populate these anyway, because they're really doing these things are just filtering the voltage on the bus going on the breadboard anyway. You may not even care to do that, but this is a reasonable place for those to go. They'll fit. And I think the design rule checker won't even complain once we get to that part of the stage in the game. Now when you get to the back silk screens, you can always flip this over like this. I think I mentioned this in the chat on one of my other videos. Here's the back copper. Why in the world is the polygon pore on the back not working? Oh, I must have deleted it when I was editing everything else. I lost the pore on the back, so it's no big deal. I can put it back in. You just want to say I'm on the ground network. Okay, run around the outside just like we did last time. All right, so now at this point, I could run a track right across here, but the metal on this is going to sit on the board. And when I heat things up or mess around when I'm putting it together, it could work its way through the solder mask and short out this output against the ground shielding on the case. So what I'm going to do, I'm going to go to the bottom layer. I'm going to just run the track on the bottom. That's all you got to do. You click bottom, go grab yourself a track, and you're drawing now on the bottom layer. All right. It's okay to be underneath the connector that's on the top. There's nothing down there to mess up the track on the bottom layer. That's fine. Of course, on the bottom layer now, we've disrupted the ability to use it as a ground plane. That's okay though, because this pin's connecting the top copper as well as the bottom, as is both of these. So this on the top will be all copper up here. So it's good enough, especially for this simple design. Otherwise, you might need to put a lot of vias around here to keep the everything satisfied if it's a high frequency design or something like that. Because you do a lot of things different in that case. And I think that's our final board. There's the bottom side track that we just put in there. No problem. Doesn't interfere with anything there. Looks pretty good. We shaved $2 off the PC board cost, probably, by shrinking it down. It's still going to be pretty sturdy. That just comes from you building a couple of boards, you know. You don't want to get so small the board snaps, but this isn't going to snap. It's going to be pretty robust. I think the connector is going to be nice. The little jack will go up the top. It'll be a nice variation of the project. So for version 3 here. All right, looking good. Let's run the design rule checks, and I think we're going to be done. Yay. Uh-oh. Uh-oh. It found a problem. What's going on here? Let's close this. There should be markers on here that says, hey, this is disconnected. Oh, these guys are not connected. Well, technically they are, because this pad connects them all together. It's upset because I didn't actually draw a line like this. Okay, now it's connected. Is this one? Yeah, there must have been a track in there before I put that capacitor in there. So now let's go ahead. I hit save. Let's do it again. Delete all the markers. Start the DRC. Looking good. Okay, looking good, fine. So it found a technical error, but not a real one. But it's always good to, check these things out. And I only put the open source hardware logo on the top this time, not on the bottom as well. No one's ever going to see the bottom anyway. So I think we're looking pretty good. There we go, version 3. I'll upload this baby to OshPark and order one. If you think this was helpful, let me know in the comments. Thumbs up, thumbs down, whatever. Thank you for watching. See you later. Bye.